What's up, Logic fans? Welcome to our section 5.8 video. So in these videos we're going to be covering our 8th section on quantificational semantics. Here we explore how to do expansions of sentences that involve the identity symbol. Let's rock. So we're going to find that expanding sentences that involve the identity symbol, such as these, is actually very similar to expanding sentences that have relations involved in them. So it will help if you review our earlier work on expanding sentences with relations from 5.7. That being said, let's suppose that you had a one-object case, a two-object case, and a three-object case to consider, like this, for example. So here you're supposed to write down an expansion of sentence 1. We're just looking at sentence 1 right now. If you had just one object, little a. Here, where you have two objects, little a and little b, and here we have three objects, little a, little b, and little c. So pause now, give that a try, and we'll try them together. Alright, well we have to start with the usual idea, right, which is the sentence, right? What does the sentence mean? This says everything is identical with itself. So, in particular, if we've got little a and little b and little c, right, in the case of just one of them, we're going to have just this, right? But as you add objects, right, you're just going to end up with constructions like this. And notice we're going to use the main connective and, right, because it's a universally quantified sentence. So none of that is changing, and it's basically the same way you would expand a sentence like, I don't know, let's take this one as our analogy, right? You would expand it, you know, RAA, and RBB, right? It's the exact same sort of process. So with that in mind, if you want to take a second to pause now and try to fill out the third one if you were unable to get it, but basically what you're going to do is, you know, add the third case, okay? And it's just like the relational analog of R for all x, RXX. All right. Now, given that, can you expand with one object, with two objects, and three objects? This sentence with the existential quantifier, at least one thing, is identical with itself. Pause now. Well, of course, if you have, you know, just the one object, it's going to be the same. It's going to be A is identical with A. But if you have two objects, right, you're going to switch these guys from the ands to the ors, right? So you're going to have at least one thing is identical with itself. So either A is identical with itself or B is identical with itself. Of course, all of these are trivially true, right? A is identical with itself, or B is identical with itself, or C is identical with itself. And that's what the expansion will look like. All right, let's shift things up a little bit, okay, and let's try it. Suppose I change this to A, and let's suppose I change this to A. All right, try sentence 1 with one object, two objects, and three objects. Pause now. Okay, well, sentence 1 says everything is identical with A. So if there's just one object, it's just going to be A is identical with A. But if there's two objects, you're going to have A is identical with A, which of course is trivially true, and B is identical with A, right? So we're just filling in this case, and you've got the logical connective and, because it's everything in your bag satisfies this description. So A satisfies it, and B satisfies it. Similarly, if you had three objects, right, it would be just like this, right? Except you would have to add the third case where C satisfies that description as well. And so it would look just like this, okay? Now, what about for this case right here? Pause now and give that a try with one object, with two objects, and with three objects. I should really say, instead of objects, individual constants, okay? Because if they're identical, it's not, you've only got one object, but with three individual constants, let's say. Pause now. Okay, so there's two big changes, right? First of all, we know we're going to have to change from the and to the ors. That is going to give us the existential part, okay? But we also know that at least one thing satisfies this description. So in the case of one object, it's going to remain the same. But you're going to have A is identical with A here, or A is identical with B. So it's going to look like that, okay? And this is fixed, right? So at least one thing satisfies this description. A is identical with it. So A satisfies it and B satisfies it. So it's going to look like that. And then similarly here, you're going to have A is identical with B, or A is identical with C, okay? So that's exactly what the expansion is going to look like. And hopefully you're seeing, you know, okay, you could carry out the pattern for 4, 5, and 6 individual constants if you wanted to. All right, let's ramp up complexity here. Let's jump into some 2 quantifier cases, right? So the identity stuff is a bit fancier, but we're going to do this here. So let's suppose I had a sentence like this, and let's suppose I had a sentence like, oh, I don't know, for this one. Let's do, yeah, we'll do it like this. Let's do, we'll just do X is identical with Y. All right, so try sentence 1 here with 1 object, with 2 objects, and with 3 objects. What would the expansions look like? Pause now. So of course we start with trying to understand what the sentence says. It says everything is identical with everything. Right? Every X in the bag satisfies the description is identical with everything in the bag, including itself. So if there's just one thing in the bag, then A satisfies the description is identical with everything, which just amounts to A itself in that particular situation. But if we've got 2 individual constants, okay, then what we're going to be doing is we're going to be expanding this slightly differently, and you'll notice it's going to mirror exactly how we expanded the relational sentence, okay? So here's your hint for you. Looks like this, right? It's going to look just like the way we did this one. So for example, you know, if everything is identical with everything, then we're going to have A is identical with A, B is identical with B, A is identical with B, and B is identical with A, right? So let's write this all out so that you can see it. So you're going to have this, and then of course we're going to have and because of the universal quantifier, right? And we're going to have A is identical with everything. So in the 2 object case, that's A is identical with itself and it's identical with B. And then of course we've got to have the same thing for B, right? Because everything is identical with everything. So B is going to be identical with A and B is going to be identical with B. Right, and of course, if you were to expand this, and let's just do it right beneath it so you can really see it, okay? You would have RAA and RAB, right? And RBA and RBB. Okay, so these correspond, right? Just like this, okay? And so that's a really nice thing to keep in mind, and if you've mastered the relation stuff, this will be very fast for you. Of course, I should note that, you know, these ones here on the end, A is identical with A and B is identical with B, we regard those as trivial, but we're going to leave them here as part of the complete expansion of the sentence, okay? And also, of course, you would only need one of these 2, since identity is a symmetric property, something we will syntactically prove in Chapter 6, and we had occasion to discuss in Chapter 4. You would really only need one of these, but still, let's leave it all out like this. Okay, so can you finish this off and do the 3 individual constant case here? Pause now if you haven't already. Okay, so basically what we're going to do, and just picture it as the, you know, the relational case RXY. Right? But basically you're going to have A is identical with everything, okay? Which is going to include C, right? And you're going to have B is identical with everything, including, of course, C, right? So you're going to have B is identical with C. It's going to look just like this. And then, of course, you're going to have the C case, right? So let's just do that one this way. So you're going to have C is identical with A, and C is identical with B, and C is identical with itself, and we don't need this last one. So that would be the complete expansion, okay? All right, so hopefully that makes some sense and the relational analogs help you out. Go ahead and try this one with 1, 2, and 3 individual constants. Pause now. All right, so it's gonna work the exact same way, right? Except of course you're just gonna have these ors in here, right? Your main connectives are going to be the ors, and notice just how much like the relations this is lining up to be. And I want to present it in a very similar way so that you gain immediate confidence with doing it, okay? And hopefully all of this is really helping you feel like you really understand what these things are saying, right? That you're getting a really strong intuitive grasp of the meaning of these sentences. Okay, let's try a couple others. Let's suppose that we mix the quantifiers, right? Just so you can actually see these examples done out. Let's suppose we had a case like this, and we had a case like this. All right, so, or rather, excuse me, we had a case like that. Okay, so let's go ahead and try a situation like this. Go ahead and pause now. Try the first one on 1, 2, and 3 individual constants. Pause now. All right, well, the first case is pretty straightforward, right? Let's start with the meaning of the sentence. For anything you pick out of the bag, there's just A in there, we're assuming, okay? A is such that there's at least one thing that it's identical with. And since there's only A in there, that's just going to get you A is identical with A. But of course, you know, this is just going to be the expansion, like a very similar thing with a relation, right? So you can imagine yourself expanding this particular statement. Okay, and instead of the R, you're just going to have the identity symbol. So try that if you haven't already. Okay, so hopefully the analogy here helps you, okay? But yeah, I mean, it's just like expanding this. You can get your RAA, your RAB, your RBA, and your RBB, which is exactly what we have here, but with the identity. And notice since our main connective is AND, of course, you still got the AND as the main connective, and the inner connective is going to be the OR. Okay, and so that's exactly what it looks like, and you can just use those sorts of analogies to help you out. Okay, try the 3-object case based on that if you haven't already. All right, so the 3-object case is just going to be, you know, the 2-object case and extend it out to cover the C cases, right? Okay, so just like the relations. So based on that, can you pause now and see if you can figure out this particular situation for 1, 2, and 3 objects? Okay, and by now, you know, the patterns should really be sticking out to you, but basically what's going to happen is you're going to end up reversing these because the inner and outer connectives are different, right? So the main connective now is going to be OR because the main connective here is the existential quantifier, right? And so similarly, when we go through all of these cases, it's going to be just like this, all right? No big deal whatsoever, and you got to love it that these patterns hold, right? And it just makes learning all of these things a lot faster and easier. I hope it does, okay? All right, so what we're going to do is we're going to spill on to a second video here. So look for 5.8b, and we'll catch you there.